This is going to be the last podcast in Chapter 4. We're going to talk about observatories in space. Those observatories that we can actually put up in the sky above the Earth. And as we put them above the Earth, we can discover some other interesting things, and there's reasons why we do that. So let's talk about that. Well, the one that everybody talks about, of course, that everybody knows about is the Hubble Space Telescope. It's 13.6 meters long. It really isn't that far or long. It's not that big, and but it's up in space, and it's a visible telescope, meaning it can see in the visible spectrum pretty much. Okay, there's some other ones out there, particularly we have Xray. Here's the Chandra Xray Telescope, a satellite. So it's a satellite and it sees in the X-ray. The reason we have to put this one up in space, and we talked about this earlier, is you can't, X-rays do not make it to the Earth, which is a good thing, otherwise we'd have big problems. So the Xray Telescope, this is called the Chandra, is a satellite orbiting the Earth, and it sends back images, if you will, although the images aren't visible, they have to false color them, and they can look at different things in the X-ray spectrum. We also have one infrared telescope. It's the Spitzer one, and so they can detect infrared. Again, a lot of infrared light doesn't make it to the Earth, which is a good thing because our atmosphere prevents it, and we've got other things, our magnetic field that prevents it, and all these things those are good things. And then we also have an ultraviolet telescope, if you will, up in space. So these observatories are up in space because we can't see things because our atmosphere stops those light. So that's a good thing. So these are the major space observatories in space. Major space observatories in space. That's kind of redundant, isn't it? All right, let's just talk about a couple other issues with that. One's called atmospheric blurring. Now, the twinkling, which we talked about a little bit earlier, of stars is called scintillation, right? It's caused by the moving atmospheric irregularities refracting starlight to bend to the bad side. Well, that's a problem, right? Well, the condition of seeing, this is not important. But if we see distorted seeing, it can be improved by adaptive optics. This is kind of a cool thing. What you can do is if you send a quick laser, isn't that cool how they think of all these things? This is like, it's like, wow, this is really cool. All right, so if you've got this twinkling thing, what do you do if you've got your cool observatory? Well, they essentially can send a laser, and then they can correct the mirrors to offset the scintillation because it's going to twinkle, and the laser kind of calibrates or sets it so that you can see it real well. I'm not sure I totally understand how it works, but I think it's pretty cool. Another huge problem for land-based observatories is light pollution. If you look at this picture, there's just so much light everywhere. We've got our lights turned on everywhere. Where can you go where the light is not going to be in the way? Because if there's light around you, you cannot see things. I mean, if you are anywhere on the east coast of the United States and you're watching this, you hardly can see the stars, I'm afraid, because if you're probably near some populated center. Where we live here in Colorado, the nice thing is this is probably Denver and Colorado Springs right here. But we live kind of up in the mountains over here, and so we're in kind of one of the darker places, so it is easier for us to see. But you've got to find a place where there's just hardly any light, unfortunately. And that's a tough place to do in this world since we have so much electrical lights and such. And so stars are cool, but you got to have the light go away. Yeah. All right, so what's the advantages of space-based versus ground-based telescopes? This will be one of the test questions, certainly. So advantages of space, of course, is there's no atmospheric blurring, and there's no atmospheric absorption. So that's a great thing, all right? But ground-based advantages, you can get a larger one. So you get better collecting power. And also, of course, if it breaks, you're right there. It's hard to fix one that's up in space. The Hubble telescope is a classic example of that, is that it broke and then they couldn't fix it because they were a long ways away from it. And eventually they sent some people up there to fix it, but it was a lot of time and energy and money and whatnot. Where are you going to put a ground-based one? Ground-based ones, of course, need to be consider weather. If you got a place that's all cloudy, that's not a good place. Humidity is a problem, so you want to find a nice dry place. And then kind of a haze from pollution, a lot of things. And then, of course, a place that's free from light pollution, or at least not that heavy in light pollution. So you want to find like a remote, dry place that has clear weather. So that's how you try to pick a cool one. So, folks, that's essentially it for this chapter. It was kind of quick. We kind of had a long podcast in number 1, and the rest of them were short. And that's on purpose because we want to kind of move on. Now that we've kind of learned how scientists study space with the telescopes, now we're going to figure out what they actually have found when they've looked up at the sky. So that's going to be really cool. So we'll see you in class.